The moment your AI decides between answering directly or calling a tool is where the magic happens. We'll break down the exact logic that lets an LLM evaluate user input, choose whether to perform calculations itself or delegate to external tools, and track every decision in the process. You'll see how the model node becomes the brain of your agent, processing messages, while maintaining full visibility into its own operations.
From LangChain, messages import system message. Def LLM call state, dict. LLM decides whether to call a tool or not. Return. Messages. Model with tools invoke. System message. Content equals. You are a helpful assistant tasked with performing arithmetic on a set of inputs. Plus state messages. LLM calls. State, get LLM calls 0 plus 1.
This demonstrates the stateful agent loop pattern, where an AI system maintains conversation history and dynamically routes between decision-making and tool execution. The pattern creates a persistent workflow that alternates between language model reasoning and external tool calls, with the state object acting as shared memory across iterations. What makes this distinctive is the explicit separation of decision logic. When to call tools from execution logic, how to call them, managed through a directed graph structure. The flow follows a reactive cycle. The language model evaluates the current state and either produces a final response or triggers tool calls, which then update the state for the next iteration. This creates a clean separation of concerns. The model handles reasoning, tools handle execution, and the graph manages control flow. The state object persists across cycles, allowing the agent to maintain context and track metrics like call counts without external storage. This pattern solves the problem of building reliable, observable AI agents that can handle multi-step tasks. It's particularly valuable for workflows requiring tool use, like calculators or API integrations, where you need both reasoning and execution capabilities. The trade-off is added complexity in graph definition, but the benefit is a more maintainable, debuggable system compared to monolithic agent implementations. Let's break it down line by line.
From LangChain, messages import system message.
Imports system message from LangChain, a specialized message type for system-level instructions to language models. This enables configuring the AI's behavior before processing user messages, like setting its role or constraints.
Def LLM call state, dict.
This LLM call function processes the current conversation state, a dict carrying message history and call count, by invoking the LLM with a system prompt and existing messages, then returns the updated state with the LLM's response and an incremented call counter. The state is explicitly stateful, tracking conversation context and usage metrics, rather than stateless, as evidenced by the mutable LLM calls, counter and preserved messages history.
LLM decides whether to call a tool or not.
This function invokes an LLM configured with tools, model with tools, on the current message history, where the actual tool use decision happens internally during the invoke call. It wraps the response in the state dict and increments the call counter, but doesn't expose the decision logic, just delegates to the underlying model's tool selection.
Model with tools invoke.
This invokes the language model with tool capabilities. The model with tools object handles both reasoning and tool execution, enabling the LLM to decide whether to perform arithmetic directly or call external tools.
System message.
Instantiates a system message from LangChain, which sets the AI's initial behavior and context. This message primes the model with its role and constraints before processing user input.
Content equals, You are a helpful assistant tasked with performing arithmetic on a set of inputs.
This defines the system message that primes the LLM's behavior. It establishes the assistant's role as an arithmetic-focused helper, ensuring responses stay on task for math operations rather than general conversation.
Plus state messages.
Concatenates the existing conversation history from state messages to the system prompt. This maintains context across multiple LLM calls, enabling the model to reference previous interactions when generating its response.
LLM calls. State, get LLM calls 0 plus 1.
This tracks LLM invocation count in the state dictionary. Uses get with default 0 to handle missing keys, then increments by 1. This pattern safely accumulates call metrics without requiring initialization. Langgraph state management pattern. The system message and LLM call function demonstrate how state is maintained and transformed between LLM interactions, with the state dictionary tracking both conversation history and call counts. The LLM calls counter must be explicitly initialized in the state dictionary to avoid key error on first invocation. This pattern forms the backbone of agentic workflows, where state persistence enables multi-step reasoning and tool orchestration.
The node that executes nothing completes every graph.